Hey everyone, welcome back to my channel leelawebdev. Today we are diving into the world of readable streams in the Node.js. How they work, why they are powerful, and how they handle the large files efficiently using the chunks and also the back pressure. So this video is a continuation of our previous session on writable streams. If you missed that, check the link in our playlist so that you can have an idea about the writable streams also. Now in this video we are learning about the readable streams. So let's clean up first the project about this one. So right now here I am having test.txt writemore.js file which we have did it, right? So I will move these two files into the writable folder. So I have created a new folder and I am moving these files into the writable folder, and I am creating another folder that is nothing but readable folder. So in this readable folder we will try to write the read thing. So let's try to implement setting up the thing. So here I will create a new file that is nothing but readbig.js file. So anything. Okay, so this is our file and I'm adding it. Let's import the fs module, require fs, and here it should be node fs/promises. Okay, first we need to read the file. So first of all we need to read the file. For reading the file, let's say that we are having this writable test.txt file, right? So let's try to run this one again so that we can have the file. Now what I will try to do is, here we are having node writemore.js file. So it is taking some chunks of file. So it has written 2 seconds. Okay, fine. Let's copy this file and I would try to paste it here so that what I would like to read this test.txt file. So it's a pretty huge file. Okay, fine. Cancel. So now we have a test.txt file. I need to read this file. So how can I read this file? First of all, let's try to open the constant file handle, or otherwise let's try to create an immediately invoked function that is nothing but like this. Okay. And here I need to call it, and here I need to keep the async. So this is our function, and here I am reading file handle read is equal to await fs dot open, and I am opening this one file path that is nothing but the test.txt file which I would be trying to read it. So this is the file I am reading it in, and so now we are opening the file with an read flag for reading. Now let's create a readable stream from our file handle. So now here for reading this one, so what I would be trying to do, constant stream read is equal to await, file handle read dot create read stream. So I will be creating a read stream directly. So I have created a read stream. Readable stream normally emit events. So if you want to get the chunks of data, we should listen to the data event. So let's try to listen to the data event. That is nothing but stream read dot on off data, and you would be getting the chunks here. Okay, chunk, and I will be trying to do the console.log of chunk. So you will be getting each chunk. So fine, that's the thing. So now let's try to run this one. Let's go here. I will be doing the CLS. Let's go into the readable, and here I will be reading node readbig.js file. So if I try to read this one, so you will be able to see each one, you will be able to get a buffer. Okay, each log shows a different chunk. Instead of loading the full file into the memory, we get it in a manageable pieces. So now what is the size of the each chunk? So let's find out this one. So what is the size of the each chunk? You will be able to see 65,486, something like that. So what is the size of the each chunk? So let's try to add here console.log chunk dot length. Chunk dot length. So now if I try to do, so here you will be able to see it is around 65,586. So by default the chunk size here is 64 KB. So because fs.create stream sets the high watermark to the 64 into 1024. So that is around, if you try to open the calculator, or otherwise I will try to open the Chrome, more than the writable stream, it will be So the internal buffer for this one, let's try to go to the Node.js. Let's go here and open the docs, and let's go to the FS module, that is nothing but file system, and here you will be having a create read stream. So here if you try to see create read stream and all those things in the options, okay, so here in the options somewhere you will be able to see high watermark. Yeah, this is the high watermark, and default is 64 into 1024. So the watermark for this read stream is 64 into 124. So if you take 64 into 124 means how much it will be? It is 65,536. Exactly these many bytes it will be having. Okay, it sets the, by default it sets the high watermark to the 64. Let's verify. We have verified that one in the Node.js docs also. So now whereas this if we compare this one with the stream.writable, where the default is just 16 KB only. So if you want to change the high watermark value, we can change it for this one. So for example, let's say that here if I want to change the high watermark value means, so here I can give high watermark to 400 bytes. Okay, if I try to give it with the 400 bytes, and if I run this one, okay, you'll be able to see the 400 bytes only. So it is taking around 400 bytes. It's taking too much time, so let it take. Yeah, so the last chunk, the data is only 90 bytes only, so you will be able to see the 400 bytes of data. So now the chunks will be 400 bytes, so we can reset it back to the default one, that is nothing but 64 KB. So I am resetting back. Okay, so fine. So now what I want to do, so we got the chunks of data, so we need to write the read chunks to another file. So now let's copy the contents of our source file into a destination file using a writable stream. So first of all, what we need to do it is, so here we need to create a file that is nothing but destination.txt file, something like this, or otherwise there is no need. So it will be created, right? So here let's try to create a file. Constant file handle write is equal to await fs dot open, and here I will be having a file destination.txt, and I would try to open this one in write mode. If the file doesn't exist, automatically the file will be created. And here I will be creating a constant stream write is equal to file handle write dot create write stream. So we have created the write stream for this one. So now we know that, so whenever we get the data, okay, so we need to write that one into here. So we got the chunks of data, that is nothing but the buffer we are getting, and here I can simply use stream write dot write of chunk. That's it. So let's try to see whether we can able to do it or not. So if I try to run this one, done, finished. Within fraction of second it is finished. And if you try to see it here, destination.txt file has been created just as same as the test.txt file. If you try to observe the file size of this one, I don't know whether you are able to see the file size or not. Yeah, here exactly the file size is 3.7 MB and 3.7 MB. We are able to see the test file and the destination file is one and the same only. Both should match exactly. And just like that, we have successfully copied a file using streams. So, but hold on. So this is not an optimal. Why? Most hard drives in our system can read faster than they can write, causing a memory buffer buildup called back pressure. Node will keep buffering unread chunks in memory, just like what happens in a tight for loop writing too fast. To simulate this, let's create a much larger file. I already have a much larger file, that is nothing but you will be having file huge.txt file. Let me copy this one and I will paste it here. So it will let it paste. So it is around 5 GB. So this file, let's try to write it in our destination file. So now, so I am creating, so it has generated around 5.07 GB of file is there. So now let's try to copy this big file using our stream based solution. So let's go to the back to the readbig.js file and now change the file of this one, source file handle read, that is nothing but what is that one, file-huge.txt file. So now I will be trying to open that one, which contains 5 GB of data. So now keep an eye on our memory usage in the activity window also. Let's try to go here, activity window, and here I will be trying to keep this one also. So let's try to minimize this one, and here I will try to write this one. So now if you try to check it here, it is going to 37, sorry, so where is that one? Node.js runtime. Yeah, the disk in this one, it is going too much. So it is going on increasing. The disk and all those things, it has went away. So now, because we are reading it quickly, okay, we are reading and writing it. So now, because while we read quickly, we are not waiting for the write to finish before reading is done. See here, memory has went away. So now here, when we are writing here, so this internal buffer has only 16 KB, and this at a time it is sending 64 KB. The remaining data is stored in the memory, and it is trying to write all things. When the buffer is more, it has to drain it. So now it has to, so we are not waiting for the write to finish before reading the next chunk. Even though this completes fast, we are still under back pressure. Okay, so when you try to take it larger files, it will have a back pressure. So now here you are able to see 5.07, it is completed very quickly. So to handle this property, what we need to do, we need to pass the read stream when the write buffer fills up and resume it after it drain. So I will try to explain you this one in our upcoming video. So how to handle this back pressure and all those things here in the stream. So this is all about the stream read data. So as far as what we have learned in this one, you learn how to read the data in the chunks, and also how high watermark affects the buffering, and we will try to learn about the memory issues with the back pressure control. So if you found this video helpful, don't forget to like, subscribe and hit the bell icon for more deep tech tutorials. Catch you in the next one video. Don't miss it. That next video we will try to handle this back pressure, how we can do it. Thank you guys. Hi everyone. In this video we are going deep into the world of Node.js streams. We will look at how to handle the massive files, gigabytes in size, using streams efficiently without blowing up our memory. We will even simulate writing 1 billion lines to a file and see how streams can help memory usage incredible low while doing a heavy lifting task like that. Let's jump right in. So for this one, we already have in our previous video a massive file that is nothing but file-huge.txt file. So that file size is around 5.07 GB. Okay, so here we are so we need to read this one. Let's read this massive file back and copy it using a read and write stream. So we renamed the file, so like file-huge.txt file. So now let's try to write it here. So that looks simple, right? So now here let's go into our code. Yeah, so here we have written something like fs.open. So these are all the create write stream we have written. This looks simple, and it is, but when I ran this first time, it totally crashed my computer. My memory usage jumped to power 1 GB, and so all this will happen. So depending on the system what you are trying to use it. So now in order to what is happening here, so we didn't handle the back pressure, a key concept when dealing with the streams. So let me show you how we can properly handle it. So now here, let's say that here we are having a stream.write. So it will be going on writing the stream.write. So what we will try to do it is, if not of, okay, stream.write of chunk. So if returns false means, then that means the internal buffer is full. So then what we need to do, so we need to pass this one. So I will be passing stream read.pass. So we have passed the thing. So now it will stop buffering the data. So what we need to do, so automatically what I will try to do it is, so here what I can do it is, so here finished. So let's try to do stream write dot on off drain. So when it is drained, okay, so then what I can do it is, I will try to do stream read dot resume. So we'll be having a method that is nothing but resume. Automatically the stream read will be resumed. So now when the buffer is completed, so it will send you a something like end thing. We'll try to see afterwards that one. So now what is happening here, so when the write chunk returns false, we call the stream read.pass to stop reading more data. Then we wait for the drain event, which tells us the buffer is ready again. Once drained is completed, we resume reading by using the streamRead.resume. So this way we let Node.js handle the flow of data smoothly without overwhelming the memory, without using more memory. So the result of this one is memory usage stayed at just 30 MB and we copied 10 GB of file. So now if you try to do the same thing, Node.js read big, so the memory will stay like this only. If you try to check the activity monitor, let's try to check it for the node. I am trying to check it for the node here. So the memory remains something like 20 MB, something like this only. So it will be slowly writing the data. So this is how it will be writing. As you can see now, after completion of this one, let it take time. So now it has been finished. So after it has been finished, if you try to see both the files, it is in the same size only. If you try to check it, refresh. So it is 5.07 GB and also it is also 5.07 GB only. So as you can see, both the source and destination files are exactly 5.7 GB. Even down to the last 4 bytes, we didn't close a single byte also. So now that is things. Now think about this one. So we are dealing with files here, but streams are not just for files. They can be used for network requests, messages, even database queries also. With streams, you can handle now 10 GB, 100 GB, even terabytes of data, all with minimal memory usage. So that is the main thing. The goal is not to avoid 100% CPU. The goal is to keep the memory pressure low. That is the main thing. So that is how you use the streams the right way, handling massive files without killing your RAM. In the next video, what we will try to do is we are going to filter the chunks in real time. For example, extract only even numbers or prime numbers from the stream before writing them to a new file. So like that we will try to do it. So now what I want to do it is, so that's it guys about this one, stream.write and what we have learned about this one. Make sure to hit like and subscribe so you don't miss this type of things. See you in the next video. Thank you. Hey everyone, welcome back to my channel leelawebdev. Today we are diving into the Node.js streams, specifically how to handle a massive file, something like, let's say that 1 billion numbers or something we are having it, right? But here is a small twist. So we have already seen about that one, how to delete, but we are only going to extract the even numbers out of that big file, so and write them to our new destination file, all while keeping our memory usage minimal. So and trust me that trying to open that file in Visual Studio Code totally crashes, but with streams no problem. Let's get on to it. For example, let's say that you are having a file which is an file_huge, which is a 5 GB. So when you try to open this one in Visual Studio Code or something any other editors, your total system will get crashed. Why? Because this total file, what it will try to do, it will try to load it in the memory and then it will show it in your Visual Studio Code. So now this means it will be taking 5 GB of your total RAM or memory. So that doesn't make sense. Instead of opening the entire file at once, so we are going to use the Node.js streams to read it one chunk at a time. So now for example, let's say that if you are having like this, means let's say that we are having a readable. Normally you will be able to know about this cat, okay, file_huge. If I try to press enter, see it is going on reading the data, showing the data, but I can do parallelly my work. Whatever the work I want to do it, I can do it. This is possible only through the streams. So the cat is using behind the scenes streams and it is sending you the chunks of data so that it is going on showing the data using the less memory usage. Okay. So that means instead of trying to drink the whole thing at once, this is like sipping from a fire hose. So efficient and also controlled. So that is what the streams will try to do it. So running this command shows us some of the file contents using a stream-like approach. Notice how our system doesn't freeze. Everything works as expected. That's because cat is reading and printing it incrementally. So that is the main thing which you need to do. So now what we need to do, so our goal is read the file chunk by chunk. Okay, so right now we are having this code, right? So our goal is to read the file chunk by chunk, file_huge.txt, extract only the even numbers from it and write those even numbers only to the file. So that means totally if you are having an even numbers means, so one alternate numbers always will be a even number. So that means if you are having 5 GB means the destination file, the resultant file will be something around 2.5 GB, half of the file. So how can you determine even numbers? A number is even if number mod 2 is equal to 0. Simple. If the remainder is 0, when divided by 2, it is even. That is the main thing. So now we are having a file underscore huge.txt file. Since we have 1 billion numbers or something like that, we are having it. And every other number is an even. The result will be something around 2.5 GB. I told you, right? So the destination file will end up with an, if it is 1 billion numbers means it will be 500 million even numbers. Right? It's half of the things it will be. So that is one thing. So now let's try to get it into the code. So first let's get into the code, and first we need to read a chunk and convert it into a string. So here we are having the chunk. So if you try to print the console.log of chunk, so let's try to show you the chunk value, and instead of taking the file underscore huge, I will take simple file. So then afterwards we can use the file so that you can able to see it clearly, or otherwise you can use the file underscore huge also, that's not a problem. And here if I try to show you the code for this one, let me show you the code for this one, how it will handle. Node read big, yeah. If I try to show you, it is showing you the buffer. Okay, so it is showing you the buffer of data. So now it is showing you the buffer of data means what you need to do. Generally, as we discussed, that the buffer data is nothing but an hexadecimal digit of a binary digit. So that means each value, each number is an hexadecimal digit. So it's a binary value. So now let's try to convert it into a string. So here I will try to do chunk dot to string of, so you can mention optionally UTF-8. By default it will be UTF-8 only. If you don't mention it also, it is a UTF-8. So now if you try to do the same thing for this one, CLS, and now you are able to see the values, we are able to get the values for this one. So what I need to do, I need to get this all the values as a chunk. So here it is displaying all things. So let's try to get the chunk. So how can I get this one? So here I can do constant numbers is equal to chunk dot to string, okay, dot split. I can use the split, and I will be using with a single space. So fine. Let's try to console.log of numbers. So what does this split do? The split does nothing. So what it will try to do, it is, for example, let's say that if you are having a 1 2 3 4 something like that, means then it will try to split it. So if you go here, CLS, so if you are having here, so let's say that constant s is equal to, okay, 1 comma 2 comma 3 comma 4 comma 5. So you are having it something like this. Okay, oh sorry, so you are having something like this, syntax inspected. Okay, so let's say that you are having a string like this. Okay, so now if I try to split it with a comma, then let's see how you will get an output. So you will be able to see that 1 2 3 4 has been, we got it. So if you are having the space also, one and the same only, so you need to split it with the space. So that is the factor what we are trying to do it. Now we are having we are splitting with this one, and let's try to see the output for this. So here I will do the node read big. So here you will be able to see it has been divided, but one empty space we are getting it here. So why we are getting this one empty space every alternate time? So let's try to see this file for that one. So that means we are using two spaces. If you go to our writable and writemode.js file, so here we are using one space here and also another space here. So that's why we are getting two spaces. So now if I try to run the same thing here, so here now you are able to see all the values, we are able to get it. But here one problem is there. If you try to observe carefully, the first digit is not looking correct. The first digit of each chunk, the first data is not looking correct, right? The first number is not looking correct. I don't know. So sometimes you are getting single digit. So single digit only all the time I am getting it. I don't know. The first number is not looking perfect. So what could be the reason? Let's try to see it. So now if you are not getting correct means, let's try to check it. Numbers of 0. let's try to check the 0 of this one. So if you try to check the 0 of this one, and also if you are getting something like this one means, so if you are getting here something like this one means maybe the last number also is not looking nice. So what will happen, let's try to see here. So numbers of I will try to check numbers dot length -2. So the before number I will check it, and also I will check the number of length -1. So whether these two are correct or not. So here I will try to show you console.log division. I will keep it. Let's see this one. And if we run this code, what will happen? Let's see. So CLS, and if I try to run this one, see the first number 448063 and the next number is not, it should be 5556, it should be, it is not there. So here this one is matching 998 and 9999, so it is matching. So that means it is the exact number is there, but number for some values the number is not there. For some values we are able to see the exact value is there. So this is because what is happening is when the buffer is when the stream is trying to read the chunk of data, so 65 KB is a 64 KB is the maximum high water limit for the readable, right? So if you are able to get high water limit reached, means the half of the digits are getting sent to the next chunk, or will be sent in the next chunk. So that is the reason. So the number is splitted into two parts. In the first part is coming in the first chunk, and second part is coming in the second chunk. So it is something like a 8-digit number, right? Each one will take the 1 byte, that is nothing but the 8 bits. So that is the reason it is taking like that. So now in order to check this one whether it is working properly or not, so that means if I try to print the number of 0, it will match here. So console.log numbers of 0. Okay. So now let's see whether we can able to get it or not. Let's try to see. So here if I try to print it here, the first one will be always correct, right? So the first one, so here you will be able to see 10,048. Okay, fine. So file descriptor, we are not closing the file handle, so that's why it is showing you. Okay, fine, that's not a problem. And if you try to check it here, so what is that I am trying to show? Numbers of length -1, numbers of 0, it's correct one, right? Let's go down. Yeah. So now these two, okay, these two, whatever you are trying to check it, these two, you need to keep it here. So that means 71 and 72. And this 4 you need to keep it here, 63 and 64. And here this 8 you need to keep it here, 647 and 648. So like this, the first value and the last value. So it the first value of this one is nothing but this a part of this. So that's why it is getting truncated. So now if you try to check it here, so we need to handle that first and last numbers, and we need to find the even numbers. So let's try to do it in the next video. So you hope you understood about this chunk thing, how the chunk values is getting differentiated in the buffer, in the streams, while we are trying to get the chunks data in the buffer. Hope you understood about this one. So I will try to we'll try to solve this issue in the next video. So that's it guys about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. Today we are diving into a super important topic for anyone working with the large files in the Node.js. How to properly handle the split characters when reading streams chunk by chunk. So if you try to see our code, so right now the code which we are trying to see, the chunk and all those things are splitted. Now if you see the output also, so it has been splitted. So let's try to understand about this one. So how to properly handle the splitting of these chunks, and also why this happens, everything we need to understand it. It sounds tricky, but by the end of this video you will understand it completely, and we will even walk through how to solve the code also. Let's try to see it. So now let's go. So when we read a data from a file in Node.js using streams, the data comes in chunks. This one you already know. These chunks are called as a buffer. There is nothing but array of bytes. So here if you try to observe carefully, let's say that you are getting it as a buffer. So imagine that, let's go to our paint. Yeah, here I will try to write it. So let's say that we are getting it as a byte. So you will be having 1, 2, 3. So going on, you will be getting around 32,182 or something like this. Okay, let's say that this is an array. So this is the chunk of data which you will be getting it. Why? Because so this one is around the read chunk, it is around 64 KB. Let me tell you, it is 64 KB. that means around in bytes, if I try to tell you, it is around 65,000 bytes, right? So maybe I am thinking 65,000 bytes, something like that. So as I already told you, first we need to understand how the buffer works. So I want to tell you how the buffer works. So let's Control Z this one all. So let's say that you are having an array. So 1, 2, 3, something like this. Okay. So this is an array, and each representation of this one is nothing but an 1 byte. Okay. This is a 1 byte. So 1 byte, it is nothing but it is represented using 8 bits. So 1 byte means nothing but 8 bits. So that means it is something like the one representation, it will be happen in something like 0, 0, 0, 0 and 0, 0, 0, 1. So this is the representation, and the second one will be represented comma 0, 0, 0, 0, 0, 0, 1, 0. So like this the array will be. So if I want to talk you about the raw data, so the chunk will be the buffer data will be stored in this format. So this is 4 bits and this one is 4 bits. Okay, and here it is 4 bits and this one is 4 bits. So I was trying to explain you that, so this chunk, this buffer will be using the encoding format UTF-8. Here 8 means each character. Okay, so you need to understand each character will be represented using the 8 bits. Okay, so if you are having 1, 2, 3, 4, something like this means, then each character will be represented with an 8 bits. So if you are having 32,810 means, so each one, this one will be stored in 8 bits, 8 bits, 8 bits, 8 bits, 8 bits. Okay, so now this is how you'll be having. Now there is no way that in the buffer, so we are using the UTF-8 format, and also the buffer inside the Node.js, it will be using the unit8 array. Okay, it is a unit8 array. It is a special type of array which stores the 8 bits of data. That is nothing but zeros and ones. So now here think that, so there is no way to split these two. So for example, let's say that it is having an index of 0, 1 and 2 means, so either 0, 1 and 2 will be splitted, okay, or otherwise 0 and 1, 2 will be splitted. There is no meaning that half of this 2 will be split, something like 1 and half. There is no meaning. That means, for example, let's say that this 2 means, so it is something like 4 zeros and 0, 0, 1, 0, right? So don't think that the chunk will be divided in between this one. The chunk will be either divided here or either divided here. So that is one thing you should understand. So if you are taking unit4 array means, then it will be divided. So if you are using UTF-4 or ASCII, something like that, any other whatever it is, 4-bit saving means, then it will be divided. So that for those type of things, we need to put a lot of effort to add those things. So you need to combine that values, and you need to do it, append those values and all those things. So that is the thing. Okay, so now let's say that imagine you are having a reading a numbers from a file. So these numbers could be something like, let's say that you are having 1, 2. So here you will be having 1, 2, 3, so on you will be going. And here you will be having a 32,182. Let's assume that. Okay. I told you that this one is an 8-bit, 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 and also this one is an 8-bit. Each character is a 1 byte. Let's assume. So 1 byte means why I am trying to tell you is 1 byte means nothing but an 8 bits of data, 8 bits of binary data. So now at the last chunk by this 32 thing, so here 65,000 I am trying to tell you, right? 65,000 bytes. Okay, 65,000 bytes means, if you want to convert into a bits means into 8, try to make it as an into 8, then it is around 63 million bits. Okay, so now each chunk will have a 63 million bits. That is nothing but it is equal to the 63 million zeros and ones. So from 1, 2 and 3, if you go on to 32,000, so let's say that up to 32, each one is a character, let's assume. So up to 3 or 32, the 63 million bits has been completed. And what will happen? So up to here, it will not care, the stream will not care about this complete number. So each one, it will treat it as a separate character only. Okay. So the data comes in chunks. These chunks are buffers, array of bytes. So now and the next chunk may contain, and this chunk, the next chunk, whichever the chunk you are getting it. So let's try to remove this one all. Let's assume that, so the first chunk of data you will be having in such a way that, so 1, 2, 3 and going on, it will be having 32. Okay, so here you need to have 182, right? In the next chunk of data you will get that 182 and comma, and you will be able to get all the remaining numbers. So here also you will be able to see the 64, and here you will be able to see the first value will be 370, like that it will go on. So here the last number and the first number is the combination. Okay, you need to understand here. So 32 and 182 are not separate numbers, they are parts of one number. So if you combine these two, 32,182, so we just split a number in between the two chunks. So now this kind of split can happen anywhere, start, middle or end, and unless we fix it, our program going to misinterpret the data. So let's go deeper and understand why this. When you're reading from a file, the stream gives you chunk based on the buffer size. I told you, right? The 64 KB. So each character is an 8 bits and each chunk is just a set of bytes. So that stream does not know or care if it's splitting a number in half or not. So that is the main thing you will be having. Okay. So now let's so why is happening? So Node.js, normally the buffers are actually unit 8 array of 8-bit unsigned integers. So that's what I am trying to tell you. And here if you are having a buffer, let's say that if you are having a buffer means, so now here you are having a buffer, so 1, 2. So let's say that this is a buffer means, so how the buffer will be saved is 0, 0, 0, 0 and 0, 0, 0, 1, and here 0, 0, 0, 0, 0, 0, 1, 0. So this is the buffer. So in the buffer, instead of showing this all the binary digits like this, it will show it in a hexadecimal format. Okay, so 8 bits, so it will show it as in 2 hexadecimal digits. So that is the reason you will be able to see. So this one will be buffer, it will write it as in buffer and arrow mark, and 4 digit, this one comes with the 4 digit, and this one comes with the 4 digit, that is nothing but 1, and here also 4 digit, and this one will be around 2. Okay, so this is the buffer which you will be able to see. So this is how it will be displaying you. For example, if it has a 1 here means the first 4 digits it will become 1 and 1, 2. So each ASCII character is also 1 byte, that is 8 bits, and each buffer element is also a 1 byte, that is 8 bits. Streams send chunks of these bytes, but they don't guarantee whole logical units like numbers. So a number like 32,000 could be split into 32 in one buffer and 000 in the next buffer. So that's it. So now, so how we can fix this one? So now what I want to tell you about this one is, so now what we need to do it is, so here we need to check in our code that, let's say that we are having a 1, 2 and going on, okay, here having going on 32 is there. Okay, and here you will be having another one something like 182 and come like this, it is there, right? So first of all we need to check in our code that, so we need to, last element we need to take and we need to keep it as an leftover or splitted. Okay, split, the split in the variable we need to add it, and we need to check that after the next chunk when it is coming, we need to check that the first element plus 1, it is matching with the second element or not. If it is matching means that no splitting has been done. If the splitting has been done means the leftover chunk which we have got it from the first chunk, the number which we have got it from the first chunk, we need to append that one. So these are all as a characters we will having, we will append this one and we need to combine it. So that is the thing which we need to do it. Or otherwise here also you can check it, the number, the last number which we are having it, subtract -1 and we should get the previous number. If we get the previous number means then this last number has not been splitted. If we are not getting last one means then the number has been splitted, so we need to add the number. So this is how we need to check the code. Leftover captures any split number, then on the next chunk we need to prepend it to the beginning. So that is the main thing which we need to do. In this way we guarantee that every number we process is whole and never accidentally split across the buffers. So that's it guys. So before wrapping it up, streams read in bytes, chunks of data, characters are 1 byte, UTF-8, buffers don't care about the logical boundaries, you need to manually manage the split data to chunk edges. So but now you know exactly how to do that one. So if you found this one helpful, don't forget to like the video, subscribe to the channel and leave a comment with any questions. Want to see how to filter the this one all even numbers, we'll try to do it. Thanks for watching. I will see you in the next one. Hey everyone, in today's video we are learning how to extract only the even numbers from our huge file containing the numbers, and also we will try to manage the back pressure, optimize performance and all those things by using the readable streams. We'll implement it. So let's say you are reading a large file that contains numbers. So we are reading a large file that containing number. Each number is separated by a space. Now here is the catch. So when reading this file in chunks, a single number can get split across two chunks. That's what we call a character split issue. So that one also we have learned. Why the chunk, the characters will split also we have seen it. Because each character is an 1 byte, that is nothing but 8 bits. So if you are having a chunk size of around 64 KB, so if you are having a 6-digit character, so 6 characters are there in one chunk, means so you can split it can get split in 3 or 2 4 something like that, it gets split. So that's why we need to catch that last number and we need to combine it with the first number in the second chunk, so that we cannot miss any numbers. So let's try to implement that issue. So we add the leftover split here, okay, chunk at the beginning of this. So now what we try to do it is, so we got the numbers, so we have learned about this one all, so where the split is happening. Let's try to check it. So first of all, what I would be trying to do it is, so we are able to get the data. So now we got the numbers, okay, so we got the numbers. So let's try to implement this number. So first of all, let's get the first number and also a second number. So here what I will be trying to do, constant first number. So first number means nothing but you will be having in the numbers of 0. So that is the main thing. So this is all it will be in the characters. I am converting into a number, and I will be having the second number. Second number is equal to plus numbers of 1. So we got the first number and second number. So how we can able to know that the first number is not the actual one, it has been splitted or not? So how can we able to know it is, if first number plus 1 is equal to second number, means then we can able to understand that that number is not splitted. So if it is not equal, means then we can able to understand that it is splitted. So let's try to understand. So now here we can have another one also, constant last number, okay, is equal to numbers of length minus 1, numbers dot length minus 1. And also here I can do constant second last number. So I can also have a second last number and plus numbers of numbers length minus numbers dot length minus 2. So these are the last number and second last number. So what we need to do it is, so first of all we are having a chunk of data, let's assume. So I will try to show you in Paint so that you can able to understand it clearly. Let's say that we are having a chunk of data 1, 2, 3, going on, you have a 32, okay, like this in first chunk. So this is total number of 32,182. So here you will be able to get it 182, and here you will be giving 32,183, like that it will be going on the thing, and here you will be having 32,181, okay. So the first chunk will be delivered the first time. So when you are trying to get the data from the stream, the first chunk will be delivered, and I am taking the last number and also the second last number, and I will try to do it last number minus 1 is equal to second last number, means then the split is not happened. If the split is happened, means what I will try to do, I will try to remove this one and keep it in one variable. The last number I will keep it in one variable, that is, let's assume that it is a split. So after keeping the value, so this entire thing I will try to calculate the even numbers and all those things, finish. So this number is kept aside. So I will be removing this one from an array. Next, when we got the second chunk, okay, I will try to take the first number and I will try to check that whether this first number plus 1 is equal to second number or not. If it is not equal, means then we can able to assume that this this one has been splitted. We already have the splitted value from the previous chunk, so I will try to append these both the things, okay, and I will replace it here with 32 182. So in this chunk only I will try to I'll try to add it, and here the last chunk also I will try to check it and I will remove it and I will add it in the split. So like this it will be going on happening. So now what I want to do it is, first I need to take this one and I need to add it. I need to pop that one. So let's go here. So here I will be going into this one. So the last number we are trying to do it, right? So if last number minus 1 is not equal to second last number, okay, if it is not equal to second last number means, then what I need to do, so then what I need to do, split is equal to, so I will be having a variable here, let split, okay, let split is equal to empty. I'll be having it like this, and here what I would be trying to do it is, so here the last number is this one only, right? So here you can have a numbers.pop. So I am removing directly numbers.pop. So I am removing it directly, and I will add that split is equal to last number. So I will add that number. That's it, finish. So we got the split, okay. So before we got the split, what we need to do, we need to calculate the first number also. So the first number means, so we need to check in such a way that if first number plus 1 is not equal to second number. So if it is not equal means, then first number and second number is not equal. So then if you are having a split means, then you need to combine the first number with the split and you need to add them. So here you can add in such a way that if split is there, so you need to check that if split is there, the first time you will not have a split. So that's why I am trying to tell you. So numbers of 0 is equal to, so here I can do split dot to string. So I will convert it to string and I will use the trim, okay, plus, so here I will add, or otherwise there is no need to add this one, and here I can use first number, so the first number which we are having dot to string dot trim, okay. So this is the method which we are having it. That's it. So now we got the number also got added. So now what I need to do, I need to capture the even numbers for this one. So here once this one is finished, so here I will do numbers dot for each. So you can use whatever the thing you want. So numbers dot for each, and here I can check that if number mod 10 is equal to 0. Then what I can do, so I am taking only the 10 decimal number. If not of stream write, if not of stream write dot write of, so we need to write the value. So here I can use something like plus, and here number plus I am adding the gap actually. So if it is not equal to, then I will do stream read dot pass. That's it. So that's it. So now what we are trying to do, we are calculating the, we are taking the first number and we are adding it if it is split is there means, and we are removing that from the last number. So that's it. So now if you try to check it, so I am using the test.txt, and here if I try to check it, the output, let's try to check this output. So here let's go into this one, and we will be having let's say that git repair markers. Let's try to check it. Somewhere we'll be having open in, yeah, open in Explorer. Let's go to the Explorer, and I will open the command prompt for this one. Let's go to the readable. Yeah, I will open the command prompt. Oh. So I have opened the command prompt. Is it opened or not? It's taking some time. Let it take. So it has been opened. Now what I want to do, so here let's try to write node readbig.js file. So now it has been converted. Now if you try to check the destination file, so let me open this destination file, show more options, open with, where is this open with, sorry. So here I can have open with, and here I will try to open in the Visual Studio Code. Let me open this Visual Studio Code. If you try to check the output for this one, So all the values are nothing but ending with 0. So that means we are only getting the values which is divisible by 10 only. So if you try to write it with the 2 means automatically you will be able to see the 2 value. So for example, let's say that if you try to change the value that even numbers means, so here I can write that if it is mod 2, okay, then you will be able to get the node readbig.js. So now it is taking some time to write it. Yeah, fine, it has written. Now if you try to take cat destination.txt file, so now here you will be able to see 584, 586, 588, 590, 592, 594. So we are able to get only the even numbers. So now from the huge file also using this stream thing, so you can able to extract only the desired even numbers. So this is how we will be splitting the values. So that's it guys about this one. So before we run this one, so like this we need to do it. So after running your script, what we need to do, we check the output file, all even numbers are not, we check the file size. So we'll check the file size also. So here this one is around 3.7 MB and this is 1.85 MB, exactly the half is there. So that is, this is also proves exactly as expected. So now what we have done, so if you want to check the timing also, you can check it, so it's not a problem. So here what we have read, so now here you can write console dot you can take console dot time, console dot time finish. Let's try to take it, let's see how much time it is taking. So when that everything is completed on rain, so here stream read, so when the stream read dot on off end, okay, so we are not, so stream write dot on finish will not be, event will not be fired. Why? Because we are not ending the, we are not using the stream write dot end, we are writing stream write dot write. But when we are using the stream read dot read, so here we are using stream read dot on data, right? When the stream read entire thing is finished, end will be fired. So here you can use this one directly. So control dot time end. Now if you see CLS, so now you will be able to get the total time, how much time it has been. So 1.796 seconds it has taken. So this is how you will be implementing this one. So now what we have did, everything you have understood about this one, how to extract the even numbers from a set of file using the streams, and also both readable streams and also writable streams. If you found this useful, smash the like button, subscribe for more development content, and let me know in the comments what you are building with the Node.js. So catch you in the next video. Fine, bye. Hi everyone, welcome back to my channel Leela webdev. In today's video we will see about the readable streams, the Node.js documentation, what it has given. So now we have already explored the writable streams, right? And now it's time to complete the readable streams also. So now here let's try to open the Node.js documentation, what they have given. Let's try to see. Let's go to the docs. So now here we need to go to the streams. So here this is the streams, and we have completed about the writable streams. Come down, so these are all the properties we have seen, and now this is the readable stream. So here you will be able to see the readable stream about this one. So now readable streams, just like the writable streams, these are the way to handle the data efficiently in chunks. They allow us to read the large files or responses from HTTP servers without loading everything into memory. And depending on what you are reading, files, HTTP requests or response, the readable stream behaves like a little differently. So here you will be able to see the HTTP responses on the client, whereas the writable streams you will be able to see the HTTP responses on the server. The same thing. So read streams like this, in all these places we will be using the readable streams, they are saying. So now the is defined by the stream.readable class. So normally if you try to see, there are two reading modes, it seems. For readable streams there are two reading modes. So what is this reading mode? So two reading modes, that is nothing but flowing and also parsed. These are the two modes which you will be having. That is the main thing which you need to understand. So readable streams in Node.js have two modes, parsed mode and also flowing mode. By default all streams will be in parsed mode only. So that's why when you create a read stream, it will be in the paused stream mode. So here somewhere they will be writing in flowing mode. So these modes are object mode, readable stream, regardless of whether it is flowing mode or okay. So all readable streams begin in a pause mode, but can be switched to flowing mode in any one of the following ways. So that is the thing. In paused mode, so if you want to read the stream readable method must be explicitly to read the chunks of the data from the stream. So now if you want to switch from paused mode to the flowing mode, so we need to add a data event handler. So just like how we have added, or otherwise you need to call the stream.resume method. This one also we have seen, and we need to call the stream.pipe method to send the data to a writable stream. So we haven't learned about this pipe method, so I will try to explain you about this pipe method in our upcoming videos. Just keep it aside for the time being. So these are the three ways which the readable stream will be converted from the paused mode to the flowing mode. By default, when we start a readable stream, it will be in the paused mode. So the readable stream can be switched back to the pause mode in any of the following ways: by calling the stream.pause mode, or otherwise you can remove by calling the unpipe method. Okay. So the only way which we know is the paused mode only, so which we have seen it. So when the stream is flowing or when the stream is coming, we are reading the data. So if you want to stop the data from reading, means we need to call the stream.pause, which we have did it. If the stream.write returns false. So now this is all they are trying to give you about this one. So if a readable switch is switched into flowing mode and there are no consumers available to handle data, the data will be lost. This can be occur, for instance, when so this is all common. So now they are trying to tell you. And the another one which they are telling is there will be three states for the two modes of operation for readable stream. So there will be three states. One is the readable flowing. So if you want to get this property, means it is telling the readable flowing null means it hasn't started. Readable flowing, if it is false, means so it has been flowing but it is paused. Readable flowing true means it is flowing. So here you will be able to see the readable flowing is null means no mechanism for consuming the stream data has been provided. So that means any of the three ways, something like data, stream.resume, stream.pipe, so nothing is provided, so that's why it will be in the null. So therefore the stream will not generate data. While in the state of attaching listener for the data event call readable.pipe method or so something like this, these all means then it will switch from readable flowing to true. So then it will convert to true. Why? Because flowing state is, or otherwise if you have paused that one means then it will be false. So that's the thing. So this is what they are trying to tell you, and they have given some simple example. So here you need to understand another one. So while you are writing the readable streams, you need to choose only one API style. So what is this one API style? Either if you want to read the data, you need to use the on-off data event or on-off readable or pipe or async address. So this is the thing. So any one only you need to use, on-off data or on-off readable or pipe or async. So using a combination of these all the things, if you try to use it, means then it will lead to a initiative behavior. So it will not be expected as expected. So that is the main thing. So the readable stream API evolved across multiple Node.js versions and provides multiple methods of consuming the stream data. So choose any one of the method of consuming data, or you should never use multiple methods to consume data. So here you know about this on-off data. On-off readable is also same like this event only data. We'll try to see it down. And pipe we'll learn about this one, or async iterators. This is the thing. So here the readable methods and events and everything is derived from the readable class. Let's try to see. Close. The close event is initiated just like the writable stream. Whenever the file descriptor has been closed means then this close event will be fired. Data event you haven't seen. So whenever you want to read the data means that you need to emit this data event. So then only you will be able to get the data. You need to attach a data event listener. So then you need to read the data. End. So when the read stream has been ended means this end event will be emitted. So then you can attach this event listener and you can able to get the data, execute the logic. Error means if any error occurs in the readable stream means then this event will be fired. Pause. The pause event, this one is emitted. This pause event will be emitted when you call the stream.pause. So when we will be calling the stream.pause, then this pause event will be emitted. So this is the readable event. This readable event is emitted when there is a data available to read from the stream up to the high configured high watermark. So normally the readable stream, the high watermark is 64 KB. So when the data in the internal buffer reaches 64 KB, then the readable event will be emitted. So then you can able to read the data. So this dot read, if you want to use it, means then it will be reading the data. So that is one thing. So if the end of the stream has been reached, calling stream.read will return null and trigger the end event. So now that's it. That's it all. So the resume event, you know about this resume event, and destroy event. So destroys the stream. So here closed, so it will return true if it is closed or not. Destroyed means if destroyed or not. Is paused means if it is paused or not. Pause means you can pause the stream. Pipe will try to see about this one. So you can apply pipe only to a readable stream. So you cannot apply to a writable stream the pipe thing. So when you this will take the destination will be always a writable stream. So when you use the readable stream dot pipe of writable stream means whatever the data is coming here, everything will be written in the writable stream, handling all the back pressure and everything will be taken care by that one. So there is no need to write all the code which we have learned up to now. So that is the main usage of this pipe. So always the pipe should be applied to a readable stream only, or duplex stream or transform stream also you can use it. Just I am trying to tell you where the duplex stream is a combination of both readable and writable. So I will try to I will explain these all the streams in the upcoming videos. So now here we will try to see about this one. So now here we will be able to see something like readable dot read. Okay, we haven't seen this one now. The read means nothing but it will read the data from the internal buffer and return it. If no data is available means then it will do like that. So you can practice this all the things. So then you will be able to understand. If you practice these all the things, then you will be able to understand these all things. Readable. So these are some experimental thing. So here you will be able to see some readable length, readable high watermark, and these all the things. Resume and set encoding. If you want to set the encoding, these all the encoding. So these are all unpipe. If you want to remove the pipe means you can use the unpipe. Unshift, this is in the old Node.js version we will be using this one. So these are all methods. Okay, wrap. So these are all methods which we can use it. Okay, so these are all experimental thing. So which are coming in the experimental. So map means so you can in the chunks, whatever the chunks you are getting in the thing, you can filter over this one, which we have applied the filter, right? The same thing you can apply over the chunks which we have applied. Is for each loop we have applied it, right? So you can apply the filter or map. These are all the things you can apply. So this is all for each we have applied the for each loop. So which we have seen it. So these are all just how we can see it. So these are all that some means it will stop immediately if the stream if the match is found. Fine. These are all array methods only which you will be able to see. Flat map. These are all experimental mode which you are getting. So still it is in the stability, it is in the experimental mode only. Reduce. These are all array methods. Whatever the array methods are there, they are applying it. So this is basically the readable stream. So almost all the things we have completed it. We have covered in our readable stream thing. Hope you understood about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.